You've learned Relativity Theory by Paul Marostica. There are other matter theory sales promotion videos numbered in this series. My name is Paul Marostica. I have invented the unifying fundamental physics theory, matter theory. Matter theory can replace all 6 professional fundamental physics theories: ether, classical, relativity, quantum, the Standard Model, and string. I am offering matter theory to one funder and first user in an historic, temporary, exclusive first sale, satisfaction guaranteed. Later, I will publish it for sale worldwide. You will not learn matter theory from my videos, but you will learn about many of its important implications. Relativity theory includes many mathematical relations useful in approximately calculating many important physics observables of objects moving with large speeds, and of objects affected by gravity. Unfortunately, relativity theory does not logically explain what is physically occurring consistent with its mathematical relations. So, with relativity theory, you can calculate, but you cannot understand. In this video, I question you about what is physically occurring consistent with specific fundamental assumptions and implications of relativity theory. I expect you to realize you cannot logically answer the questions. You need the answers to understand relativity theory, and the answers are not in relativity theory. So I expect you to learn, in using relativity theory, you cannot understand what is physically occurring, so you can only hope your calculations accurately represent reality. You've learned relativity theory. So you've learned the special theory of relativity. You've assumed the speed of light in free space is the same constant for all observers, 2.99792458 times 10 to the 8 meters per second, independent of both the speed vector of the light source and the speed vector of the observer. So, what is physically occurring to cause all light particles to move with the same constant speed in free space, while other particles can move with changeable speeds in free space? Oh, you did not learn that. And what is physically occurring to cause that constant speed of all light particles moving in free space to be 2.99792458 times 10 to the 8 meters per second? Oh, you did not learn that. And what is physically occurring to cause the constant speed of all light particles moving in free space to be independent of both the speed vector of the light source and the speed vector of the observer? Oh, you did not learn that. Also, you've assumed the laws of physics are mathematically the same for all observers having constant speed vectors relative to each other, implying you've assumed all motion is relative. What is physically occurring consistent with this mathematical assumption? Oh, you did not learn that. And possibly you've assumed linear mathematical relations between the relative position vectors of any two of those observers in the position vector dimension of their relative speed vectors. What is physically occurring consistent with this mathematical assumption? Oh, you did not learn that. Okay, so you've mathematically derived the special theory of relativity's 2 fundamental equations relating an object's position vector and time observed by any one constant speed vector observer, relative to its position vector and time observed by any one other constant speed vector observer. Then, possibly, together with those 2 fundamental equations you derived, you've assumed any conservation of momentum vector can always be observable by all constant speed vector observers to derive the special theory of relativity's 3 most fundamental implied equations. The special theory of relativity's 3 most fundamental implied equations apply to any massive object having a speed vector relative to an observer, and they imply the faster a mass of object's speed vector relative to an observer is, the more its mass is increased and its time is decreased, and its length is decreased in the position vector dimension of its relative speed vector. So, what is physically occurring to cause each of these three most fundamental implications of the special theory of relativity? Oh, you did not learn that. Then, using equations you've already assumed and implied, you've derived more equations, which are the special theory of relativity's implications for the observable speed vector, momentum vector, and energy of a massive object having a speed vector relative to an observer. So, what is physically occurring to cause those implications of the special theory of relativity? Oh, you did not learn that. Anyway, you've learned more than enough to consider the results of the theory experiment called the twin paradox. In the twin paradox, 1 out of 2 identical twins both leaves and returns in a rocket. The other twin observes the twin in the rocket moving, so the special theory of relativity implies the twin in the rocket should return having aged less in the time they were apart because of the time decrease for relatively moving objects. But the special theory of relativity's most fundamental assumption is all motion is relative. So it also implies the twin in the rocket observes the other twin moving, so the other twin should return having aged less in the time they were apart because of the time decrease for relatively moving objects. So in this theory experiment, the special theory of relativity has two contradicting implications. Each twin ages less than the other twin, which is a paradox. This is the time part of the twin paradox of the special theory of relativity. The special theory of relativity also implies, while the twins have different relative speed vectors, each twin has more mass than the other twin, because of the mass increase for relatively moving objects. This is also a paradox. This is the mass part of the twin paradox of the special theory of relativity. And the special theory of relativity also implies, while the twins have different relative speed vectors, each twin has less length in the position vector dimension of their relative speed vector than the other twin, because of the length decrease in the position vector dimension of the relative speed vector for relatively moving objects. This is also a paradox. This is the length part of the twin paradox of the special theory of relativity. So the special theory of relativity's assumptions logically result in paradoxes in all three of its most fundamental implications: its implied mass increase, time decrease, and length decrease of all relatively moving massive objects. Did you learn? Each of these three paradoxes proves the special theory of relativity's most fundamental assumption, all motion is relative, is incorrect. Oh, you did not learn that. To try to eliminate the twin paradox, possibly you added one other assumption to the special theory of relativity. Possibly you assumed accelerating motion is absolute. Using this one added assumption, only the twin in the rocket was in absolute motion in accelerating to start, to reverse direction, and then to stop, even if each of the accelerations occurred only for a short time. So only the twin in the rocket aged less in the time the two twins were apart, because of the time decrease for relatively moving objects. Also, using this one added assumption, while the twins have different relative speed vectors, only the twin in the rocket has gained mass, and only the twin in the rocket has lost length in the position vector dimension of the relative speed vector. The one added assumption, accelerating motion is absolute, contradicts the special theory of relativity's most fundamental assumption, all motion is relative. But, in the twin paradox, using it eliminates the contradicting implications. did you learn this has the effect of changing the paradox of the special theory of relativity's twin paradox from having contradicting implications to instead having contradicting assumptions? Oh, you did not learn that. Now let's try the general theory of relativity. So you've learned the general theory of relativity. You've determined any object's motion in a small room on a stationary planet having a constant downward gravitational acceleration could be indistinguishable from its motion in a small room in free space having an equal magnitude constant upward inertial acceleration. So you've assumed any object's motion resulting from gravity could be indistinguishable from its motion resulting from its own inertia. So you've assumed the force of gravity does not exist, and instead you've assumed the momentum and energy of matter and radiation curves spacetime, and you've assumed curved spacetime affects the inertial motion of any object in it. The most common illustration of this uses a two-dimensional projection of a three-dimensional analogy of curved four-dimensional spacetime. But if spacetime is just space and time together, how could spacetime, having no substance, physically affect the motion of an object in it? Oh, you did not learn that. And independent of how similar the motions of objects in the two rooms are, wouldn't the physical cause of gravitational motion, a field, necessarily be significantly different from the physical cause of inertial motion, an acceleration? Oh, you did not learn that. Anyway, you've also learned the general theory of relativity is not really very general. It is only a theory of gravity. It is not a theory of everything. So, you've learned relativity theory. And you've learned many of relativity theory's high-accuracy theory experiment determinations have been tested for equality with the high-accuracy reality experiment determinations they are intended to represent, and they tend to be equal, but with low accuracy. Did you also learn, in testing high-accuracy theory experiment determinations for equality with the high-accuracy reality experiment determinations they are intended to represent, if no errors have been made, then low-accuracy equalities imply the theory is somehow incorrect? Oh, you did not learn that. I now propose a theory experiment having results I suspect relativity theory cannot determine. Assume in free space are many identical clocks, each having a different constant speed vector. Which clock or clocks function fastest? Remember, these clocks will be real, identical, functioning physical mechanisms. The real laws of physics will determine how fast each clock functions. I suspect relativity theory, assuming all motion is relative and/or accelerating motion is absolute, cannot accurately determine which clock or clocks function fastest. A reality experiment similar to this proposed theory experiment already exists in global positioning system satellites. My unifying physics theory, matter theory, does not use physically unexplainable mathematical assumptions, does not use analogies, and does not result in paradoxes. Matter theory is a more accurate, fundamental, physically logical, unifying theory of everything. Matter theory's simple, intuitive, fundamental particle assumptions imply more accurate, physically logical, relativistic quantum-like mathematical relations. These implied physically logical, relativistic quantum-like mathematical relations are independent of relativity theories and quantum theories' physically illogical mathematical relations. So matter theory can replace both of those theories, making both relativity theory and quantum theory obsolete. Because matter theory's assumptions are physically logical, in using matter theory, you can always understand logically what is physically and mathematically occurring. We are not confused by logic, so we do not waste time and effort arguing about logical theories. Instead, we use them as they are intended, to explain, determine, and make use of things. In my proposed theory experiment, matter theory can determine which clock or clocks function fastest. If you want to learn real physics, you need to learn matter theory. If you might like to become the historic, temporary, exclusive first owner of matter theory, I invite you to email me at paulmarostica@tbaytel.net. If you are interested in matter theory, I invite you to email me at paulmarostica@gmail.com. The end.